This Zoom session is being brought to you by the Fractal Hexfire. All right. Okay, today we'll be going over 766, which is synthetic division, and 67, solving rational equations. Just a second. Villegran, you just joined, didn't you?
Yes.
I hear you. All right, fine. Synthetic division. This is for a specific type of division, dividing a polynomial by x minus c. It's a very specific kind of division. All right, and it's basically, well, it goes through the same steps, but in a lot more compact fashion. It's sort of like when you do reducing solving a linear system by using matrices rather than elimination on the matrices rather than on the whole system. You just drop a lot of x's and y's and pluses and minus signs and so on. Okay, so for example, we'll divide 3b squared minus 31b plus 13 by b minus 3. Okay, so here you divide sign 3b squared minus 31b plus 13 inside and b minus 3 outside. Okay, so we divide leading terms. 3b squared over b is 3b. That goes into the quotient. 3b times b minus 3 is 3b squared minus 9b. Subtract minus 22b plus 13. All right, divide minus 22b by b, get a negative 22. That goes into the quotient times b minus 3 is minus 22b plus 66. And subtracting it minus 53. Okay, so we have the ratio. 3b minus 22 minus 53 over b minus 3. Now, we'll abbreviate this by a process called synthetic division. We'll start with a 3, negative 31, and 13. We put those numbers here. And instead of a b minus 3 outside, we'll put a positive 3. So there's going to be a flip of signs here. We put when I have a b minus 3, we'll divide by we'll put a positive 3 here. We'll have a complementary reversal in a few moments. Here's what we do. We took this, okay, we bring down a 3, and we multiply by this 3, and we get a 9, the same 9. Well, not quite the same 9. This is a negative 9. This is a positive 9. We're multiplying by a positive 3. And instead of subtracting, we'll add. And so minus 31 plus 9 is a minus 22, which is the same 22 we got here. Now, again, we're going to multiply by a 3 to get a positive, to get a negative 66 opposed to the positive 66. Here we subtracted, here we add, and get a negative 53. So here we have a 3 minus 22 and a negative 53. Well, this corresponds to 3b minus 22 right here. And this corresponds to negative 53 over b minus 3. So there's two reversals. Instead of a minus 3, we'll have a plus 3. Instead of subtracting at each step, we'll add at each step. So there's a kind of a zigzag going on here. From an entry here, we multiply by 3, and then from here we go down by adding. Times 3, add. So times 3, add. Times 3, add. So plus 3 at the end instead of a negative 3. And adding downwards instead of subtracting. All right. So it's much the same process, except there's this reversal of sign here, and instead of subtracting, we add. Comes, and it gets the same results. Let's try this. 4t squared cubed, minus t minus 18 over t minus 2. Now, 4t cubed, 0t squared, we need a 0, like a placeholder, minus 1 for minus 1t. And it's minus 18. Now here, and since we're dividing by t minus 2, we'll put a plus 2 out here. And each step we'll do a zigzag. And then when we go down, we add. And when we go up and to the right, we multiply by 2. So bring down a 4. Okay, it's a 4. Times a 2 is an 8. Plus a 0 is an 8. Times a 2 is a 16. Plus a negative 1 is a 15. Times a 2 is a 30. Plus a negative 18 is a 12. And so 4, 8, 15, and 12. So you get a 4t squared plus 8t plus 15 plus a 12 over t minus 2. And again, we could, if you did the long division, you'd get the same numbers, only instead we'd have a negative 2 and we'd have subtraction. So it's a mutual cancellation of reversals. So there we go, we get that. Or here, x minus 4x squared plus x cubed plus 6 over x plus 1. Now, okay, this is all deliberately scrambled up. Let's write it from lowest power to smallest. X cubed minus 4x squared plus x plus 6, same as this. This x plus 1, we want to write it as x minus a negative 1. So we'll put this negative 1 out here, and a 1, negative 4, 1, 6 in here. And again, we zigzag. Every time we go down, we add. Every time we go up and to the right, we multiply by this negative 1. So bring down a 1, you get 1. Times a negative 1 is a negative 1. Add to a negative 4, you get negative 5. Times a negative 1, you get 5. 1 plus 5 makes a 6. Times a negative 1 is a negative 6. Add 0. We have a 0 remainder. We're going to get x squared, 1x squared, minus 5x, plus 6, and then plus 0 remainder. Now, okay, mentioning remainders. Now, if we have a fraction, p of x over x minus c, we'll get a quotient plus a remainder over x minus c. So in particular, so we can distribute throughout by multiply x minus c throughout, and we'll get p of x equals q of x times x minus c plus the remainder. Now, if in particular we set x equal to c, then this term cancels out as a 0. We'll get p of c equals r. So the remainder, 0 here, 12 here, is the polynomial evaluated at c. So this is a cheap and easy way, actually easier than just plugging it in, of evaluating the value of a polynomial at c. So for example, 2x cubed plus x plus 2 is p of x. What is p of 3? Well, here we go. 2x cubed, 0x squared, 1x plus 2. Put a 3 out here. So we zigzag. Every time we go down, we add. Every time we go up and to the right, we multiply by 3. Bring 2 and nothing down, you get 2. Times 3 is 6. Plus 0 is 6. Times 3 is 18. Plus 1 is 19. Times 3 is 57. Plus 2 is 59. So p at 3 is 59, this remainder. Here we have x to the fourth minus 2x cubed plus x squared minus 3x plus 2. What is p at negative 2? Well, 1x to the fourth minus 2x cubed plus 1x minus 3x plus 2, evaluate at negative 2. So we zigzag. Every time we go down, we add, and every time we go up and to the right, we multiply by negative 2. So adding down, you get 1 times the negative 2 is negative 2, plus a negative 2 is negative 4, times the negative 2 is positive 8, plus a 1 makes 9, times the negative 2 is negative 18, plus a negative 3 is negative 21, times the negative 2 is 42, plus a 2 is 44. Therefore, p at negative 2 is 44. So we have some examples. 5x squared minus 27x plus 10 over x minus 5, what's that? Okay, here we'll do it by long division. Well, all right, 5x squared minus 27x plus 10 divided by x minus 5. Take ratio of leading terms, 5x squared over x is 5x into the quotient. 5x times x minus 5 is 5x squared minus 25x. Subtracting, and remember in log division we have to do subtraction rather than adding. 5 minus 5 cancels, negative 27 minus negative 25 is minus 2x, so minus 2x plus 10. Divide leading terms, minus 2x divided by x is negative 2, that goes into the quotient. Negative 2 times x minus 5 is minus 2x plus 10. Whoop, all cancels, there's no remainder. So the ratio will just be the quotient, 5x minus 2. Okay, here we have 3b cubed minus 31b plus 13 over b minus 3. So 3b cubed plus 0b squared, there's no b squared term, minus 31b plus 13. Inside the divide sign, outside you put the b minus 3. So 3b cubed over b is 3b squared into the quotient. 3b squared times b minus 3 is 3b cubed minus 9b squared. Subtracting, 3 minus 3 cancels. 0 minus negative 9 is plus 9. 9b squared minus 31b plus 13. Divide 9b squared by b, get 9b, that goes into the quotient. 9b times b minus 3 is 9b squared minus 27b. Subtracting terms, here negative 31 minus negative 27 is negative 4. So negative 4b plus 13. All right, divide negative 4b by b, it's a negative 4 into the quotient. Negative 4 times b minus 3 is negative 4b plus 12. Subtract throughout, and we get a remainder of 1. So this ratio equals the quotient plus the remainder over the denominator. 3b squared plus 9b minus 4 plus 1 over b minus 3. Now here, they're deliberately scrambling it up. X minus 4x squared plus x cubed plus 6 over x minus 1. What's that? Well, again, we'll want to rewrite this in leading from highest power down to the lowest. So after rewriting, it's x cubed minus 4x squared plus x plus 6 all over x plus 1. All right, x cubed minus 4x squared plus x plus 6 divided by x plus 1. Divide the leading terms, x cubed over x is x squared into the quotient. X squared times x plus 1 is x cubed plus x squared. Subtract, left with a negative 5x here, plus x plus 6. Divide leading terms, minus 5x squared over x is negative 5x into the quotient, times x plus 1 is minus 5x squared minus 5x. Subtract, x minus negative 5x is x plus 5x, that's 6x, plus a 6. Subtract, divide leading terms, 6x over x is 6 into the quotient. 6 times x plus 1 is 6x plus 6. And when you divide, there's 0 remainder. So with no remainder, it means that the ratio will just be the quotient. So the ratio is x squared minus 5x plus 6. All right. Okay, much the same thing's happening here. Maybe I should be doing this by synthetic division, but I'll keep using it the other way. 8 minus 3x plus 7x squared plus 2x cubed over x plus 5. Okay, write it down in highest powers to lowest. 2x cubed plus 7x squared minus 3x plus 8, all divided by x plus 5. All right, here we go. We'll put this in here, x plus 5 out here. Again, okay, we divide leading terms. 2x cubed over x is 2x squared into the quotient. 2x squared times x plus 5 is 2x cubed plus 10x squared. Subtract terms. We're left here 7 minus 10, that's a minus 3x squared, minus 3x plus 8. And divide leading terms, 3x squared over x, or minus 3x squared over x is minus 3x into the quotient. Minus 3x times x plus 5 is minus 3x squared minus 15x. Subtract throughout. These cancel. Negative 3 minus negative 15 is negative 3 plus 15, that's 12. 12x plus 8. 12x divided by x is 12 into the quotient. 12 times x plus 5 is 12x plus 60. Subtract, and we're left with a remainder of negative 52. So the ratio is the quotient plus the remainder over the denominator, 2x squared minus 3x plus 12 from here, plus negative 52 from here, divided by x plus 5 from here. Now here we have used synthetic division to evaluate p at 2, where p of x is x cubed minus 4x squared plus x minus 2. So 1, negative 4, 1, negative 2, we put those numbers here, with a 2 out here. And again, we do a zigzag, where each time we go down, we add, and then each time we go up and to the right, we multiply by this 2. Bring down a 1 is 1, times 2 is 2, plus negative 4 is negative 2, times 2 is negative 4, plus 1 is negative 3, times 2 is negative 6, plus negative 2 is negative 8, and there we have it. P at 2 is negative 8. All right. Okay, that's it for